Hello students, welcome back. I am Rinkesh sir and today we'll continue with exercise 6.5 of chapter number 6, that is applications of derivatives. We'll complete the first two questions. Now let's begin with the third one. Okay. Question number 3 has 8 sub questions. So I will solve few of them. Okay, 2 or 3 of them, and rest I'm giving you to do it by yourself. So let's take the first one. First, fx is equal to x squared. So steps, first find out f dash x, that is 2x. F double dash x, that is 2. This is our step 1. Now let's find out the critical point. The critical point is the point where f dash x is equal to 0. That implies 2x equal to 0. That implies x is equal to 0. So this is our critical point. Okay. Now f double dash 0, now that is a constant function too, so that is greater than 0, hence local minima at x equal to 0. The point x equal to 0 is called the local minima. Now let's find out the local minimum value. For that we need to find out f of 0, that is equal to 0 square, and that is 0. So the local minimum value is at x equal to 0, and it is f of 0 is equal to 0. Clear? So this was about the first part of question number 3. Just note it down. Okay, the second one, it's similar to first, you solve it by itself. Third and fourth, both are similar, so I'm solving the fourth one. Third one, you solve it by yourself. Fx is equal to sin x minus cos x, and it's also given that the value of x is from between 0 to 2 pi. So now let's say f dash x, derivative of sin x cos x, derivative of cos x is minus sin x, or it will be plus sin x. F double dash x, derivative of cos x minus sin x, derivative of sin x is cos x. Now for critical point, f dash x equal to 0. So that implies sin x minus cos x equal to 0. So sin x is equal to cos x. That means tan x is equal to 1. Sin by cos, it will be tan x. So this implies that x is equal to, now see, it's from 0 to 2 pi. So it will be in first quadrant, and third quadrant tan is positive. So pi by 4. And the other one is third, so pi plus pi by 4. So that will be equal to 4 plus 1, 5 pi by 4. Okay. Sorry, we made a mistake. F dash x is cos x plus sin x. We took sin x minus cos x. So let's change it. So cos x plus sin x equal to 0. That means sin x equal to minus cos x. So sin by cos, tan x is equal to minus 1. So now the value of tan is minus 1 in second and third, fourth quadrant. So in second quadrant, it will be pi minus pi by 4. And in third quadrant, sorry, fourth quadrant, 2 pi minus pi by 4. Because at pi by 4 value of tan is 1. So x is equal to 3 pi by 4 and 7 pi by 4. Clear? Let's put this value in f double dash x. F double dash 3 pi by 4. So this will be minus sine 3 pi by 4 plus cos 3 pi by 4. The value of sine 3 pi by 4, again I can use pi minus pi by 4. So pi by 4, it's 1 by root 2, and in second quadrant sine is positive, so minus 1 by root 2, minus sine as it is. Cos 3 by root by 4, so it's again 1 by root 2. Okay, but it is in second quadrant, so minus 1 by root 2, it's minus 1 by root 2. So this will be equal to minus 2 by root 2 So minus root 2 less than 0. Therefore, local maxima at x equal to 3 pi by 4. Now f double dash 7 pi by 4. So this is minus sine 7 pi by 4 plus cos 7 pi by 4. Okay, so now sine 7 pi by 4, again pi by 4, so 1 by root 2, but it is in fourth quadrant, so it will be negative minus 1 by root 2 into minus plus 1 by root 2, and cos is positive in fourth quadrant, so it will be again 1 by root 2. So this is equal to 2 by root 2, and that is root 2 greater than 0. Therefore, local minima at x equal to 7 pi by 4. Clear? Now let's find out the values. F of 3 pi by 4, that will be equal to sin x, that is sin 3 pi by 4, minus cos x, that is cos 3 pi by 4. So that will equal to sin 3 pi by 4, 1 by root 2, cos 3 pi by 4 minus 1 by root 2, so minus of minus, plus 1 by root 2. So this will be equal to 2 by root 2. So root 2. Okay. Now for local maximum, f of 7 pi by 4 sine 7 pi by 4 minus cos 7 pi by 4. Sine 7 pi by 4, that is 1 by root 2. Sorry, minus 1 by root 2 because it's in fourth quadrant. And cos, again it's positive. So minus 1 by root 2. So that is minus 2 by root 2. So minus root 2. Clear? So the maximum value is plus root 2 and the minimum value is minus root 2. So I can write down that local maximum value is at x equal to 3 pi by 4 and f of 3 pi by 4 equal to root 2, and local minimum value is at x equal to 7 pi by 4 and f of 7 pi by 4 equal to minus root 2. Clear? So this was about the third sum of question number 3. Just note it down. Okay, now let's see some other. Now let's see the last, that is eighth one. Okay, question number 8. So fx is equal to x into root of 1 minus x and x is greater than 0. Positive. F dash x uv, we will use x as it is, derivative of this 1 upon 2 root 1 minus x into d by dx of 1 minus x minus 1 plus root of 1 minus x into d by dx of x 1. So this will be equal to minus x upon 2 root 1 minus x plus root of 1 minus x. Now let's take the LCM. So 2 root 1 minus x, this will be minus x plus 2 root of 1 minus x into root of 1 minus x, 1 minus x. So this will be to minus x plus 2 minus 2x. So 2 minus 3x upon 2 root 1 minus x. Okay, now f double dash x will be a lengthy one. So what I will do, first I will find out the critical point and then we'll find out f double dash x. F dash x equal to 0. What does this implies? 2 minus 3x upon 2 root 1 minus x equal to 0. So 2 minus 3x equal to 0. So x will be equal to, or 3x will be equal to 2, or x is equal to 2 by 3. This is the critical point. Okay. Now let's see f double dash x. F double dash x will be equal to, for that I need to write on first fx 2 minus 3x upon 2 root 1 minus x. So f double dash x taking u by v. So denominator square 4 into 1 minus x, because root of 1 minus x into square, it will be 1 minus x. Now u as it is, sorry, v as it is, into d by dx of 2 minus 3x. So let me write down directly. Derivative of 2 minus 3x, that will be equal to minus 3. Minus 2 minus 3x as it is, d by d, or let me write down d by dx of 2 root 1 minus x. Okay. Say why I have used this shortcut, because when I put 2 by 3, this term will become 0. 3 3 cancel, 2 minus 2 0. So no need to waste time in finding out the derivative. So now I will use directly f double dash 2 by 3, that is 2 into square root of 1 minus 2 by 3, and minus 3 into 2, that is minus 6, minus 2 minus 3 into 2 by 3 into d by dx of 2 root 1 minus x upon 4 into 1 minus 2 by 3. Now this 3 3 gets cancelled. So this will be 0. So this whole term we can eliminate. So this will be equal to 6. 3 ones are 3 minus 2, that is root 1 by 2, upon here 3 minus 2 4 into, sorry, not 2, 1 by 3. Okay, 1 minus 2 by 3, that will be 1 by 3. And here also 4 into 1 by 3. Here, so this will be equal to 2 threes are, sorry, 2 twos are, 2 threes are. So 3 by 2 into this 3 will go in the numerator. Okay, so 3 threes are 9. I will write down 9 by 2 into root of 1 by 3. Okay, and we were also having this negative sign, minus. So it will be minus 9 by 2 into 1 root by 3, root of 1 by 3. Now, so as we are having minus sign, it will be less than 0. Therefore, local maxima at x equal to what value we do? 2 by 3. Now, to find out the maximum value f of 2 by 3, that will be equal to 2 by 3 into square root of 1 minus 2 by 3. So 2 by 3, 1 minus 2 by 3, root 1 by 3. So it is 2 upon 3 root 3. Clear? Okay, we can also rearrange in this way. Multiply by root 3, divide by root 3. So root 3 into root 3, 3 into 3, 9. And numerator 2 root 3. So f is having local maximum value at 2 by 3 at x equal to 2 by 3, and f of 2 by 3 is equal to 2 root 3 by 9. Clear? So this was about question number 8. Just note it down. 8th of 3rd. Now let's move to the next question. Question number 4. Prove that the following function do not have maxima or minima. So if we don't get any value such that f dash x equal to 0, it will not have any maxima or minima. So let's start with the first one. Fx is equal to e raised to x. F dash x, that will be again equal to e raised to x. Now whatever value of x we will take, e raised to x will never be equal to 0. That cannot be equal to 0. Hence no maxima or minima possible. Clear? The second one, g of x is equal to log x. So g dash x, that will be equal to 1 by log x. Okay, now see the function gx is only defined when x is greater than 0. Clear? We can only find out the value of log x when x is greater than 0. Sorry, g dash x will be 1 by x, not 1 by log x. So now if we take x greater than 0, then definitely 1 by x will be greater than 0. So g dash x, that can never be equal to 0. Hence no local maxima or minima possible. Okay, let's see the third one. Hx equal to x cube plus x square plus x plus 1. So h dash x, this will be equal to 3x square plus 2x plus 1. Now h dash x equal to 0 implies 3x square plus 2x plus 1 equal to 0. Clear? To solve this, let's find out the discriminant d. B square minus 4ac. What is b? 2, that is 2 square 4 minus 4 into a 3 into c 1. So this is 4 minus 12 and that is minus 8, that is less than 0. That implies square root of d not possible. That means there are no such real roots. So h dash x cannot be equal to 0. Hence no local minima or maxima possible. Okay, so this was about question number 4. So just note it down. Now let's move to the next, that is question number 5. Question number 5. Find out the absolute maximum value and absolute minimum value of the following function in the given interval. Absolute maximum, absolute minimum means the global maximum or minimum value. Means first the value at critical point, then at the interval boundaries. Means minus 2 and 2 in this question. Now maximum from all three and minimum from all. Okay. So let's solve it. Then you will understand. Fx is equal to x cube. So f dash x, that will be equal to 3x square. Okay, now that f dash x equal to 0 implies 3x square equal to 0, that implies x is equal to 0. So this is the critical point. Okay, so now f of 0, 0 cube, 0. F of the upper limit, that is minus 2, that is minus 2 cube, that is minus 8. F of 2, that is 2 cube, that is 8. Now absolute maximum means from all the values from the critical point and from the x of the value about the boundary intervals. Now the maximum from all these three will be absolute maximum and minimum will be absolute minimum. So absolute maximum value is at x equal to, which is the maximum, 8, and x is 2 and it is 8, and on the other side absolute minimum value is at x equal to minus 2, right? Because it is minus 8. This is the minimum at x equal to minus 2. And it is minus 8. Okay. So remember, for absolute maximum and absolute minimum, find out the value of f at critical point. And if the interval is from a to b, then find out the value of f at a and f at b. And then the maximum from all this will be the absolute maximum, and minimum from all this will be absolute minimum. Here, so note down the first part of question number 5. Okay, now let's see the second one. I'm solving the second one. Third and fourth, I'm giving you to do it by yourself. Let's solve the second one. Fx is equal to sin x plus cos x. What is the interval? 0 to pi. So first step, f dash x, that is equal to derivative of sin x, cos x. Derivative of cos x minus sin x. Now find out the critical point. So f dash x equal to 0 implies cos x minus sin x equal to 0. Therefore cos x equal to sin x. Whenever I take cos x on this side, it will be sin x by cos x. So that will be tan x, and that will be equal to 1. Now when does the value of tan x is 1? That implies x is equal to pi by 4. And also, now see, this is from 0 to pi. In second quadrant, tan is negative. So there is only one critical point, that is x is equal to pi by 4. Remember, there can be more than one critical point. Then you need to verify from all the critical points as well as the boundary terminal a and b. Now f of pi by 4, sin pi by 4 plus cos pi by 4. So this is equal to 1 by root 2 plus 1 by root 2. So that will be equal to 2 by root 2, and that is equal to root 2. Root 2 ones are root 2 root 2. F of pi by 4, we got root 2. Now the lower interval, sorry, lower limit f of 0, that will be equal to sine 0 plus cos 0. Value of sine 0, 0, value of cos 0, 1, and that is equal to 1. Now f of pi, the upper limit, upper boundary, that is equal to sine pi plus cos pi. Value of sin pi, that is 0, and value of cos pi minus 1. So that is minus 1. So which is the maximum from root 2, 1 and minus 1? Root 2, that is 1.41. And which is the minimum? Minus 1. Okay. So I will write down that absolute maximum value is at x equal to pi by 4, and it is root 2. On the other side, absolute minimum value is at x equal to pi, and it is minus 1. Clear? So this was about the second part. Third and fourth, I am giving you to do it by yourself. Okay, but remember, there can be more than one critical point. So for that, check the values of all the points for the given function. Okay, just note down this one. Okay, students, so that's it for today. Thank you.